viewers, by the name of Mtc. We are going to look at mathematics that is senior 2. We look at expansion and the factorization. This is common in paper 1, that is 456 is topic 1. It can appear in section A, it can also appear in section B. We can have an example here. Expand the following as possible. Level 1, number 1, we have A into 2 plus B. We open brackets. So this is supposed to be 2A, that is 2 times A, it gives it 2A plus AB. Now we look at number 2, where we have A into A plus 2. This is supposed to be A squared plus 2B. Now we look at number 3, we have xy into x plus y. So for this case, we shall multiply xy by x. The answer is supposed to be x times x. It gives xy plus we have xc y squared. Then you also have level 2. Number 1, we have x into x plus 2 plus 3 into x plus 4. For this case, we need to first deal with the first bracket, then also we deal with the second bracket, whereby this one gives x squared plus 2x plus 3x plus 12. Where possible, we correct like terms. This is supposed to be x squared plus 5x plus 12. This is what we call a quadratic equation in the form of x, that is x squared plus 5x plus 12. Let us look at Roman number 2. We have p into p plus 1 plus 4 into p minus 1. We have that 4. Let us deal with the first bracket, where we have x squared plus px. Then in the second bracket, we shall multiply 4 by p and also negative 1. This one gives you 4p minus 4. Remember, minus and the plus, it gives a minus. So we can correct like terms. We have p squared plus 5p minus 4. This is also a quadratic equation. We shall look at the case 3. Over number 1, we have x plus 2, then x plus 3. For that case, we need to open the two brackets, whereby the first element, it will affect the elements within the second bracket. This is x into x plus 3, like that. And also, we have a 2. This switch is going to affect the second bracket. We have 2 into x plus 3. Let us open brackets here. X times x is x squared plus 3x. Then the second bracket, there is 2 into x plus 3. This is supposed to be 2x plus 6. 2 times 3 gives a 6. Let us correct like terms. This is x squared plus 5x plus 6. We look at case 2. In case 2, we have x minus 7, then x plus 2. Similar to case 1, x is supposed to affect elements within the second bracket. Remember theta for this negative. We have negative 7 into x plus 2. We shall open brackets. For this case, we have x squared plus 2x. When you multiply x by x, it gives x squared. Then x times 2, it gives 2x. We have negative 7x. That is negative 7 times x, it gives negative 7. Then negative 7 times 2, it gives negative 14. We correct like terms. We have x squared. Then in here, it is 2x minus 7x. It gives 5x, but minus. Plus, it is supposed to be minus. It is supposed to be minus 14. Supposed to be minus 14. Let's look at another example of that form. We have x minus 2, then x plus 10. We see that this x is going to affect that bracket, and also this negative 2 to affect that bracket, such that we shall have x into x plus 10. Minus 2 into x plus 10. We see that here we have x into x plus 10. We have x times x, that is x squared, plus 10x, plus 10x, minus 2 into x plus 10. This one gives 2x minus 20. When you multiply negative 2 by positive 10, it gives negative 20. Let us simplify further. We have x squared plus 10x minus 20. This one gives x squared plus 8x minus 20. This is also a quadratic equation. Yes, I want to give more examples of that form because it looks to be a challenge to most of the students. We have x minus 5, then x minus 3. We have minus and minus. Try to play with those two negative. Negative 5 and negative 3. We see that this x, it affects that bracket, and also that minus 5. So this one gives x into x minus 3. Minus 5 into x minus 3. So let us simplify it further by opening brackets. X times x, it gives x squared minus 3x. Then negative 5 times x, it gives negative 5x. Negative 5 times negative 3, that is negative and negative, it gives a positive. When you look at the enemy of your enemy is your best friend. So this one gives a plus, but it is a plus 15. We correct like terms, or we simplify further. We have a date of 3 and a date of 5, so that date it is going to accumulate. So this one gives the x squared minus 8x plus 15. You should note this. We have a date of 3 and a date of 5. So it is going to accumulate to 8. So our answer is x squared minus 8x plus 15. I want to give a trial which should be done during your free time. But you should always try to do a number at least every day or every hour. You should always calculate a number during your free time. What size here? Try 1. Expand the following. Expand the following by opening brackets. Roman number 1, we have x into p plus 4. Roman number 2, we have x into x plus 5x. Next, we have x into x minus 2 plus 5 into x plus 2. Next, we have x into x plus 4, then plus 2 into x plus 4. We also have this one, that is x minus 5, then x plus 1. Next, number 6, that is x minus 4 into x minus 3. So try to do this work during your free time. Let us look at the square of brackets. This is also under expansion. Let's look at an example. Is example 2. We say that expand the following. Expand the following. Number 1, we say that a plus b square. If they say square of brackets, it means that you multiply that bracket by itself. This is a plus b, also a plus b. We are supposed to have two similar brackets with a similar elements. Remember the first bracket and also the second bracket. In other words, elements in the first bracket affect the elements in the second bracket. This is a into a plus b. Also b, it is going to affect the second brackets. Let us open brackets. This is supposed to be a squared plus a b. Also here, we have b times a, it gives the ab. Remember, multiplication is commutative. ab is the same as ba. So, let us look at b times b. It will give us b squared. Finally, our answer is a squared plus, we have ab plus ab. This is supposed to be 2ab plus b squared. We look at example 2. Look at example 2. We have n minus b squared. At first we had a plus. Now we have a minus. Let us check. Is it going to give us the same answer? Oh. Here we say that a minus b, then a minus b. That is what we have. Let us check. This one, it affects, and also this is supposed to be a into a minus b. Then minus b into a minus b. This one is supposed to give us a squared minus a b minus a b again. Remember the commutative rule? Somebody can say ba. But it is the same as ab. Minus and minus gives it plus b squared. We correct like terms. This one gives it a squared minus 2ab plus b squared. I want you to note this. That a plus b squared, it is not the same as a minus b squared. That is case 1. Case 2. This is not the same. We have a plus b squared. This is not the same as a squared plus b squared. Please, you should note that. We look at Roman number 2, Roman number 3, where we have a minus b squared. This is not the same as a squared minus b squared. I want to give more examples of that form. We have x plus 2 squared. This is supposed to be x plus 2. Then x plus 2. This is supposed to give us x squared. When you multiply x by x, then x by 2, this is 2x. Then 2 times x plus 2x. 2 times 2, it gives positive 4. When you collect like terms, we have 2x and 2x. This one gives a x squared plus 4x plus 4. However, somebody can also use this identity. Somebody can also use this identity. Somebody can also use this identity that a plus b squared is the same as a squared plus 2, ab plus b squared. And when you look at our question, it is x plus 2 squared. Our x is a, and our b is 2. So when you substitute in, this one gives you x squared plus 2 times a. Remember, our a is x, and our b is 2. This is 2. B is 2, that is b squared. This one gives you x squared plus 4x plus 4. It gives the same answer, meaning that the identity exists. The identity exists. Number 4, we have x plus 4 squared. This is x plus 4. Then x plus 4. That is the square of the brackets. We have 2 brackets, similar brackets with the same elements. We see that the elements in the first bracket affects elements in the second brackets. However, we have x into x plus 4 into x plus 4. This is supposed to be x squared plus 4x. That is the first bracket. In the second bracket, we have 4 into x plus 4. This one gives you 4x plus 16. Remember, 4 times 4, it is 16. But there is a student who's going to write 8. We are squared, but not doubling. So here we have x squared plus 8x plus 16. This is our answer. Let us look at Roman number 5. Roman number 5, we have p minus 7 squared. This is supposed to be p minus 7, then p minus 7. Remember, we are using minus, but not plus. We expand in terms of p. We have p into p minus 7, then p minus 7 into p minus 7. Let us open. This one gives the p squared. P squared. Then p times negative 7, that is negative 7p. Negative 7 times p, negative 7p, minus and minus, it gives a positive. But this one is supposed to be positive 49. And we shall have p squared minus 14p plus 49. This is our answer. We can have a child here. Child to expand the following. Expand the following by first opening brackets. Roman number 1, we have x plus 1 squared. Roman number 2, we have x plus 10 squared. We also have x minus 11 squared. We have x minus p squared. We can also have p minus x. So I want you to compare the two answers for Roman number 4 and Roman number 5. Check. Is it going to give us the same answer? Expansion by using the identity of difference of two squares. Expansion by using the identity of difference of two squares. We see that the identity states that a minus b and a plus b, the answer is a squared minus b squared. So whenever you see similar elements within two brackets by different signs, that's what we call difference of two squares. Let us check. Let us check by expanding a minus b, then a plus b. This is the same as a into a plus b minus b into a plus b. Remember, elements in the first bracket affect the elements in the second bracket. For this case, when you multiply a times a, it is a squared. Then a times b, it is a b. Minus b times a, the commutative law, it gives a b. Minus b times positive b, it gives the positive b, it gives minus b squared. Remember, negative with a positive, it gives a negative. The friend of your friend is your friend. Last, the friend of your enemy is also your enemy. So here, we can simplify further. We have a squared. These are similar elements. A plus with a minus, it gives a 0. Last, this one, it gives a b squared. I want us to use this identity to expand. Let's have an example here. Example, expand the following by using the identity. By using the identity a minus b, then a plus b equal to m squared minus b squared. We have case 1 here. We have x minus 4, then x plus 4. This is the same as, let us use this identity. It is the x squared minus 4 squared. But what is 4 squared? Remember, we are squaring only 4, but we are leaving out the negative. So the answer is supposed to be x squared minus 16. Another case, we have x minus 10, then x plus 10. Same elements, but different signs. We're going for difference of 2 squares. This is x squared minus 10 squared. This is x squared minus 100. So that is what we call difference of 2 squares. So by using the identity of difference of 2 squares, expand the following as far as possible. Number 1, we have x minus 1 into x plus 1. Number 2, x plus 7, then x minus 7. Next, we have x plus 4, then x minus 4. Next, we have 2p minus 3, then 2p plus 3. Dear students, I want you to note this. M minus b squared. It is not the same as a minus b and a plus b. These are 2 different identities. Next, a plus b squared. This is not the same as a squared plus b squared. But we know this, that a minus b and a plus b, this is the same as a minus b, then a plus b, which gives a squared minus b squared. I want us to look at factorization. It's the opposite of expansion. Before you go in for factorization, you should know expansion. Factorization, I repeat, is the opposite of expansion. We look at this. Factorization. Let us look at an example here. Example 1. Factorize the following completely. Factorize the following completely. We look at case 1. That is Roman number 1. We have 2m plus 6. When you observe, there is something common, and that is 2. The common factor of 2 and 6, it is 2. So we shall pull it out, or we factorize it out. In other words, dividing 2m by 2, it gives the m. Dividing 6 by 2, it gives the 3. We can have another case. We have ab squared plus a squared b. Yes, for that case we see that there is a common factor. First of all, you can see there is a. So this is a into, when you divide by a, it will give b squared. Plus, we have a squared. Divided by a, it gives a. That is ab. Still, we shall not say that this is the final answer. There is another factor within. That is b. So we put it out, we shall have ab into b plus a. So this is our answer. Let's look at example 3. We have 3x squared plus 48. There is something common. That is between 3 and 48. The common factor is 3. So we shall divide this one by 3. It gives the x squared. Then divide this one by 3. It gives the 16. So that is our answer. When you look at Roman number 4, with the 3x squared plus 48x, this is a different case. Something common, that is 3 into x squared plus 16x. For this case, we shall not say that this is the final answer. There is another common factor, that is x. Put it out, we have 3x into x plus 16x divided by x, it gives 16. Let us look at for another example, that is Roman number 5. We have x into x plus 7 plus x into x plus 7. For that case, we see that we have similar elements, meaning that the common factor is x plus 7. Outside, we have x. Then even here, we have plus x. So our answer is going to be 2x into x plus 7. Allow me to give more examples of that form. We have x, then x minus 10 plus 5 into x minus 10. When you observe, we have two similar brackets. In other words, the common factor, it is this bracket, is common. So we put it out, or we factorize it out. We shall have x minus 10. When you cover this, outside, there is x. You also cover that, because it is a common factor, we have plus 5. So this is our answer. Allow me to give a trial here. Trial 1. Factorize the following. Factorize the following completely. Factorize the following completely. Case 1. We have 5x plus 15. Case 2, we have 3x minus 27. Case 3, we have x into x plus 2 plus 4 into x plus 2. Lastly, it is x into x minus 1 minus 7 into x minus 1. Try out for that during your free time. Try out to that during your free time. Let us look at this one also. Factorization of the form x squared plus bx plus c. This is what we call a quadratic equation because it has x squared and bx plus c, where this one is the sum and this one is the product. That one is the product. Let us recall. We can say expand a plus x into b plus x. For this case, the element in the first bracket, it affects the element in the second bracket. That is a into b plus x x into b plus x. Let us open the brackets. This is ab. That is ab plus ax. Then here we have plus bx plus x squared. It is also quadratic equation. But let us modify it. We have x squared. Then here we see that there is something common there. That is x into a plus b plus ab. We shall take this one to be the sum because of the addition sign. Well, last here there is a multiplication between a and b. That's why we say products. That's why we say products. Write it down, a sum and the product of the following quadratic equations. Roman number 1, we have x squared plus 5x plus 6. When you recall, we said that x squared plus a plus b, x plus ab. This is our product. It is our sum. It is our sum. Last, this one is the product. Therefore, the sum of x squared plus 5x plus 6, it is 5. And the product is 6. The constant, it is always the product. Allow me to look at Roman number 2. We have x squared minus 7x plus 10. Our sum is negative 7. Remember to quote, it should be negative. Should you set 7 the ordinary mark, let it be negative. Then our product is positive 10. Should somebody send negative 10, we shall also deny a mark. It should be positive. First fitting, we have x squared minus 8x minus 7. For this case, the sum is negative 8. Last, the product is negative 7. I'll give a child here. That is, write down the sum and product of the following product equations. That is number 4. We have x squared plus 10x plus 16. Next, x squared plus 13x plus 30. Next, we have x squared minus x minus 90. Before we look at solving the quadratic equations by factorization, we need to know the sum and the product. Let us look at this example. Let us look at this example. Solve the following quadratic equations by factorization methods. In the scenario 2, we look at the factorization approach. We also look at the graphical approach. Then scenario 3, we shall look at the completing squares and also the general method, which sometimes we call the bulldozer. So we have our number 1 here, x squared plus 5x plus 6 equal to 0. If an expression is of this form, we call it a quadratic equation. We have the sum. Our sum is 5. We also look at the product. Our product is 6. Identify any two numbers, that is A and B. When you add, it will give you 5. And when you multiply, it will give you 6. Check within the factors of 6. That is the 2 and the 3. I said check within the factors of 6. Somebody can say 1 and 6. It is correct, but it does not favor 5. 1 plus 6, it does not give us 5. That's why we consider 2 and 3. When you add, it gives a 5. When you multiply, it gives a 6. Let us substitute in the common factors. You substitute them where there is a 5. So this is x squared plus 2x plus 3x plus 6. Remember, we said factorization is the opposite of expansion. So we are going to look at these numbers. Look at the first two numbers. There is something common. That is x. We said that x into divided by x. That is divided by x. It gives it plus 2. We shall go in here. Something common, that is positive 3. We shall write here plus 3 into, divide by 3, it gives the x. Divide by 3, it gives the 2. Still, this is not enough. We shall not conclude that this is the answer. Go ahead to pull out the common factor. Our common factor is x plus 2 into x plus 3 equal to 0. In other words, pull out x plus 2, it gives a positive x. You pull out x plus 2, it gives a positive 3. This is what we have. But this is not the final answer. The question it was, by factorization method, solve the quadratic equation. For either x plus 2 equal to 0 or x plus 3 equal to 0. Dear students, if we have positive here, it means that our answer is going to be negative 2. So when of the answer is negative 2, then also here x plus 3, our answer is going to be x minus 3. So these are the values of x. We can call the roots of the quadratic equation in the form of x squared plus 5x plus 6. Remember, we are using factorization method to solve the quadratic equation. And here we have x squared plus 7x plus 10 equal to 0. Our sum is 7. Plus the product, it is 10. Common factors, we look at 10. Within 10, I can see there is 1 and the 10. But 1 and 10 cannot help us. Let us try to see 2 and the 5. 2 plus 5, it gives a 7. 2 times 5, it gives a 10. So 2, 5 can help us. 2, 5 can help us. Let us substitute. We have x squared plus 2x plus 5x plus 10 equal to 0. Remember, we are looking for the values of x, or the roots of the quadratic equation in form of x squared plus 7x plus 10. Now look at the first two numbers. There is the x. When you look at these two, we have x divided by x, it is x. Divided by x, it gives a plus 2. Plus, look at these 2. There is something common between 5 and 10, that is 5. So 5, pull out 5. 5x divided by 5, it gives the x. 10 divided by 5, it gives the 2. Remember to equate it to 0. We look at this. We see that x plus 2, it is common. Cover this. There is something common, that is x. You also cover that. We look at 5 equal to 0. For either x plus 2 equal to 0 or x plus 5, it is a 0. Dear students, I said when it is positive, just take a negative. Our x value, x1 is negative 2. Also here, x2, which is negative 5. So these are the roots of the equation in that form. We look at example 3. Example 3, we have x squared minus 7x plus 12 equal to 0. Mind the negative. mind the negative. So our sum is negative 7. Should somebody say positive 7, we shall deny a mark, meaning that you lose all the 4 marks. Product, our product is 12. It is positive, but not negative. Identify the common factors. 2 numbers, when you multiply, you get positive 12, and when you add, it gives you negative 7. We have 1 and 12, cannot tell it. We have 2 and 6, cannot tell it. But if you hear before, can help us. If before gives the positive 12. When you add, it gives the positive 7. But here we have negative. So let us modify. We shall say negative 3, negative 4. When you multiply this, it gives you positive 12. You add negative 3 plus negative 4, negative 7. Let us substitute x squared minus 3x minus 4x plus 12 equal to 0. We factorize. Look at these 2 numbers. We have x into x minus 3. You also look at these 2. There is something common. That is negative 4. Put it out. It is negative 4. Negative 4 divided by negative 4x. It gives you positive x. Positive 12 divided by negative 4. It gives you negative 3 equal to 0. When you are factorizing, you should always maintain these 2 brackets. These 2 brackets are supposed to be similar. That's why we say the common factor is x minus, cover that, we shall have x, cover this, we shall have minus 4 equal to 0. For either x minus is 0, and also x minus is also 0. So we shall draw conclusion. Therefore, x equal to positive 3, or x2 equal to positive 4. Allow me to give a trial here. Try to do this work using the given example. Trial 1, solve by factorization method. Alright, read the question and understand it well. If they say by factorization, the someone who's going to say, but I know how to use a general method, or the bulldozer, or the graphical. Yes, you get a same answer, but you get no mark. We say that by factorization method. Case 1, we have x squared plus 5x plus 4 equal to 0. Case 2, we have x squared plus 7x plus 6 equal to. Case 3 is x squared plus 8x plus 15, which is 0. Next, x squared minus x minus 20, that is a 0. Next, x squared plus x minus 30 equal to 0. Next, we have x squared. We have x squared plus x minus 42, which gives it a 0. Yeah, try out to that to work. application of object key equivalence visualization. We shall have an example here. We shall have an example here. Shall have an example here. The figure below shows a rectangular triangle with a height xc with a height xc centimeters and the base 2 into x plus 3 centimeters. The figure below shows a right angled triangle with a base x centimeters and the height 2 into x plus 3 centimeters. If its area is 40 centimeters. If its area is 40 centimeters, find the value of x. Number 2, its height. Find its height. In our solution, we need to know how to find the area of a rectangular triangle. We say that the area of the rectangular triangle is given by a half base height. Remember, the area is given as 40 centimeters squared. This is a half times the base. Our base is x. These are centimeters. And the height is x into x plus 3 centimeters. So for this case, this is supposed to be 2. For this case, we can reduce. This 2 goes with a 32. We have 40. The units are uniform. Centimeters squared. Also here we have centimeters squared. So we have x into x plus 3. We shall expand the brackets. When you expand, we have x squared plus 3x minus 40. This is what we call a quadratic equation. It has a sum. Our sum is 3. The product is negative 40. Common factor. Check within the factors of 40. Within the factors of 40, you can see 10 and 4. Cannot tell it. But it is 8 and 5. 8 and 5. When you add, we don't have 3. So let us modify. It is 5 which is negative. Such that when you add this, it gives a positive 3. When you multiply, it gives a negative 40. So let us say x squared plus 8x minus 5x minus 40, this is 0. Look at the first two numbers. We have x, then x plus 8. Here it is negative 5. That is x plus 8. Identify something common. That is x plus. Then also x minus 5 equal to, for either the first bracket equal to 0 and the second bracket is also 0. And for my case, x equal to negative or x is 5. However, we don't have a negative for this test. Let's say we shall do a conclusion. Therefore, x equal to 5. But these are centimeters. The x value is 5. Then Roman number 2, we want also to find out the height. Our height is 2 into x plus 3. So we say that the height is 2 into 5 plus 3. Our height is 16 centimeters. Note this. We have two values of x. The one is negative, another one is positive. But we shall leave out this one which is negative, because we don't have a negative distance. We don't have a negative distance. Try it out during your free time. The figure above shows a rectangle. The figure above shows a rectangle with a width x centimeters and the x plus 5 centimeters. If its area is 14 centimeters, find the value of x, hence find its perimeter. Find its perimeter. Study figure above with the x centimeters and the x plus 5 centimeters. If its area is 14 centimeters, if its area is 14 centimeters square, find its find the value of x. And hence its perimeter. Try number 2. Number 2. Now the figure above shows a rectangular floor with the sides x meters by x plus 2 meters. If its area is 15 meters squared, find the value of x. Allow me to look at the second example also. This is under number base, or it is under bases. We have 1, 2, 3. 1, 2, 3. Base n equal to 83. Base 10. Solve for x. It's supposed to be n. Solve for n. We need to expand. Into a uniform base, that is base 10. This is 1 times n plus 2 times n plus 3 times n. Give powers. When you are giving powers, let the power be on n. N is our base. Should the power be out of the bracket, means that your answer is not going to be correct. So this is supposed to be 83. Now we have a uniform base, that is base 10. This is n squared plus 2n plus 3. Remember the number power 0 is 1. This is equivalent to 83. We shall correct like terms. Let 83 cross to the sides. This is going to be n squared plus 2n minus 80 equal to 0. Our sum is 2. The product, negative 80. Common factor, we have 10 and 8. But of the two numbers, one is supposed to be positive. That is 8. In summary, we have n squared plus 10n minus 8n minus 80 equal to 0. We shall summarize everything in the form of n plus 10 and n minus 8 equal to 0. So that is what we have, but the question was solve for n. Consider the first bracket equating to 0 and also the second bracket equating to 0. So for either n equal to negative 10 or n equal to 8, we shall draw a conclusion. Therefore, n equal to 8. We don't have a negative base, that's why we are considering n to be 8. Yeah, for today, we have looked at the factorization, the expansion. Allow me to stop here for today. We shall continue from there next time. But remember, COVID is real. COVID is real. You should always put on your mask. Put on your mask. Avoid moving up and down. Thank you.